Hello everyone, my name is Walid Hakoum and I'm doing a project about a center of mass detection. So, uh, and by the way, this project is for the biophysics class MECH 307. So the purpose of this project is to determine where the center of mass is for an enclosed shape by two random boundaries. Now, when I say random, it's not completely random, it's random to some sort, because doing random functions was much harder than I actually thought. So I was thinking at first, I started with doing sine sine function and a cosine, and uh, arrange them in a way that I could know where they would meet. So I would know how to set the lower and upper values for the bisection method to get the roots and to find out where exactly they meet, because I'm going to need that to find the area, and I'm going to need the area to find the x and y coordinates. So I ended up doing a negative parabola for the upper value and then a positive parabola for the lower value. And now these two parabolas, well, it's when I say a parabola, I mean an even power to the x. So it's just easier for me to predict where exactly, or at least what is the range that the root could exist. Where these two functions meet. So I used the bisection method to get the root of these two functions. And the way it works is that you have to select two x values around the root and you plug them into your function, and then you get opposite values and you take the average, opposite signs, I mean, the values of opposite signs, and then you take the average and you get a certain sign, either positive or negative, and then you select the opposite sign to that from your previous x values, and you take the average again, and you keep doing it over and over and over until you get closer to the real root. And here I set the tolerance to be 1 part of a million. So actually 10 millions. So it's very precise. And for integration, to get the area, I used trapezoidal method. So in short, trapezoidal method, it just means that you cut the area that you wanna solve for. So you cut it, and then you draw a line on the function in between these two these boundaries, and then you would calculate the area of the resultant trapezoids and sum all the areas to get your area. And the more trapezoids you make, obviously you get closer to the real area, or you get more precise, you get more precision. And I used here 10,000 trapezoids. I thought it would be enough. And then let's try it. So when you run it the first time, you would get center of mass here. It would tell you the center, the x coordinate of the center of mass, which is almost 0 here, and the y coordinate, which is actually very close to 0 too. Okay. Yeah, I thought it was something interesting. So I decided then to take it to the next level. What I just wanted, I moved everything I have in here to a function, and I put it inside a function called the center of mass. So what this function outputs or returns is the area. So I wanted to just know how the area would behave as the as you run it more than once. Let's try it 10 times. It's completely random. Now 100 times. Seems to take a long time. It's kind of had a have ups and downs. Let's try 1000. For the next trial, I want to try 25 bins. Seems to be taking a while. Okay, I'm not gonna wait too long on it. Let's just run it 100 with 25 bins. I just want to know what would happen. No, it doesn't seem to be working okay. Yeah, it seems like 10 was a good choice. Yeah, so that would give you a better idea of how it works, but yeah, this is my project, and thank you very much.